In this video, we'll see what is exception and how do you handle exception in Java. So first thing is, what is exception actually? So exception you can define as a runtime error, which obviously happens at runtime, not at compile time, and which disrupts the normal flow of your code. And how you handle this runtime error is known as your exception handling. So before going deeper into how do you do exception handling in Java, first let's see what are the types of errors. So you can classify errors into these three types. You can have syntax error, logical error, or runtime error. So syntax error, you can say every programming language has its own syntax. So if you don't follow it properly, you will have some error which will happen at compile time itself. So your program won't even run if it has syntax error. It won't even compile, so you won't be able to even run it. For example, suppose I have this program and I forget some semicolon. So in Java, every statement should end with a semicolon. So that's a syntax error. And at compile time itself, if you see, it will give you that error, right? That you need to insert semicolon. Or if I miss a bracket here with if, that is also a syntax error, because that's what Java needs, a bracket with if for your condition. So these are like syntax error, and you won't be able to run your program because of compile time errors. So first you have to fix all these errors, then only your program will run. Second is logical error. So logical error is something when your logic is not correct. So this error will happen when your logic, what you have written, is not correct, and this is going to be your biggest nemesis when you code. So for logical error, you won't get any compile time error, right? Because syntactically your code is correct, but what you have written may not be correct as per your requirement. So thing is, when you run it, you may get a wrong output in some of the scenarios or in all the scenarios. For example, if we take this program itself, so here we have a method which tries to find the maximum of these two numbers, right? But somehow in my logic, while I'm comparing, when I'm supposed to return A, I've returned B. When I'm supposed to return B, I've returned A. So if you see, there is no error, but when I run it, I'll get a wrong output. It is giving maximum is 7, though it is 18 in this case, but because I have written it wrongly. So if your logic is wrong, that's when you will get the logical error. Third is runtime error. So that's where your exception comes into picture. So again, this is something at compile time you won't have any problem. For example, if we take this program, so what we are trying to do here is we have a scanner and we take two input from user, and then we divide first number from second number, and then we print this result what we get in a separate method. So you see, it runs properly, and if I give a correct output, I get everything. First number 8, second number 4, so it will do the division. Then I get this print also, print line calling method. Then it prints the result also as 2. But if I run it and I give second number as 0, that's when I'll have a runtime error or an exceptional condition, because I'm trying to divide a number by 0, which is not possible. So that's where it will throw an exception. You see, correct? So now if you see, it is throwing a exception, which is arithmetic exception. Reason is divide by 0 at this line, because I'm trying to divide by 0. So before going any further how you can handle it, again let's first try to understand what happens internally when an exception is actually thrown, or when an exception happens in your program. So when you have any exceptional condition occurring in your code within a method, it will occur, right? So here we have in main method itself. So that method will create an exception object. So first thing is your Java execution will stop at that exceptional condition. So here we'll get that, right? So it will stop here and it will create an exception object. So in Java, there are many different exception classes for different exception scenarios. So we'll see that hierarchy a bit, but here for this division, it will throw arithmetic exception, which is one of the exception. So that will be the type. So that exception object which is created, that contains the type, what type of exception it is, some information about the error, and the state of the program when this error occurred. So all that you can see here, correct? Type, some information, and state of your program. So it is happening in this method at this line. So all this information it gives as stack trace. So first thing is it will create this exception object, then it will throw it or hand it over to the runtime system. So once this exception is thrown, then it will look for the code which can handle this exception. So it will go through the call stack. We have only main method here, but you may have different methods that also I'll try to show as an example. But here it will look for a code which can handle this exception. Obviously, we have not written any exception handling code yet. So in that case, when you don't have any exception handling code, then it will be processed by default handler. So Java itself gives you a default exception handling if it is not able to find any code which can handle the thrown exception. So default handler, what does it do? It will print the stack trace from the point at which the exception occurred and also terminate the program. So that's what you can see here happening. So it will, exception happens here at line 14 because of division by 0. So it will create an exception object and throw it. It will look for some code which can handle it. There is none. So default exception handling takes over, which prints the stack trace. So this is your stack trace and terminate the program. So you can see nothing after that, whatever is there is executed, which means your normal flow is disrupted because of the exception. So that's what you mean by exception disrupts your normal flow. So now we come to the actual part, which is exception handling. So for exception handling in Java, there are 5 keywords which you use. So there is try, catch, finally, throw, and throws. For this video, we'll concentrate on try, catch, and finally. And syntax for exception handling is something like this. So you'll have try, then you may have multiple catch also, and a finally block. So try is something actually which is used to enclose your code. So wherever you think that an exception may occur, that code you enclose in try block. As here, you have to anticipate that okay, user may enter number as 0, that will result in an exception. So you can enclose this whole block in try. So this becomes try block. So now you have enclosed your code in a try block where exception may occur. So it will still throw this exception if you enter second number as 0. Now how will you handle it? For that you use catch block. So catch block is used to handle the exception which is thrown in the try block. What you'll do is you'll have a catch block, so it throws an exception. So you'll have a catch which catches this exception. Here you have to give the type of exception which may be thrown. So we know it will be arithmetic exception. And then how you handle it. So for now, I'll just print a message where I can just say problem occurred. And this exception object which is created also gives you some methods. So one of the method is get message, which gives you the cause of the error or some message why this error happened. So now with this, if you see, when I run it, I am getting at least some error and my program is not terminated. So for a user, you can see, right, as a user, if I'm using this program, I'm not interested in getting your stack trace and where which line you are getting error, and showing this also looks very unprofessional. You should give some meaningful message, and if possible, you should be able to continue with your program, not terminate it. So now if you see, we are getting some proper message, not the whole stack trace which exposes my code and line where I'm getting error. And if I want, I can also continue with the program. For that, I'll have to bring some of my code outside. But if you see here also, one thing to notice is it throws exception here, correct, in this line, 14th line. So here, same process, it will create an exception object and throw it. Now it looks for the code which can handle it. So now we have, so it comes here. Throws arithmetic exception, sees a block, catch block, which can handle arithmetic exception. It comes here, prints this line, 21. But as you can see, still all this is not happening, whatever is written after exception. So some code loss or execution loss is always there, even if you are handling the exception. Now, based on your requirement, you may have to decide whether you want to terminate or you want to continue with your code. In this scenario, if I want to continue, what I can do is I can bring this outside here. That means I have to bring result also outside because it is a local variable within this try block right now, so this won't be able to see it. So I can bring it here, result equal to 0, and here. So if it is not able to do, at least I can print 0 now. And I'll just put one more division message here. So now if I run here and some 0, so that exception is thrown. Now if you see, problem occurred, it is still same flow. Exception object is created at line 15, throws it, catches it here. Here it is handled, so it prints this message, problem occurred, message division by 0. And after that, if you see, it is continuing now. My code is not terminated. So I still see calling method and it calls this method with result is 0. So now at least I am able to continue with my program. So that is your basic exception handling, where you have a try block. So all your code which you think may throw an exception, you enclose it within try block and then you handle it in catch block. And as I showed you here in syntax, you can have multiple catch blocks. Here also it shows the same thing. You can have more than one catch block. And from Java 7, actually, you can have multiple catch statement also. So let's try to do it both ways. So within this code, if you see, it can throw one more exception, which is because of this scanner. It expects an integer value. If I don't give it an integer value, it will throw a exception. So suppose I give some character here or alphabet, I get an input mismatch exception because it is expecting a integer here. So again, since I'm not handling it, I'm handling only arithmetic exception. So again, same thing happens. It comes here and it throws a runtime error. which is this exception. Then it sees, are you handling it? No, we are only handling arithmetic exception. So it goes to the default exception handler, which again does the same thing. Prints the stack trace and terminate the program. So I can have a second catch block also, where I can say input mismatch exception, and same thing here. So now I'm handling both exceptions. You see here, now if I give problem occurred, okay, this doesn't give me a message. So what I can do is I can give myself problem occurred, entered input not of correct type. So now it can handle both these exceptions. If I give a wrong value, I get this input mismatch exception is handled. If I try to divide by 0, it will go to the arithmetic exception. Correct. So here let's go through the hierarchy also a bit, which I'll try to cover in more detail if I do a checked and unchecked exception. But for exception also there is a hierarchy. So throwable is the root class of all the exception classes. From that you have two child classes, exception and error, and from exception again you have different classes. One branch which directly inherits from exception, one branch which inherits from runtime exception, which in turn inherits from exception. So parent class is throwable, then you have exception. So that means, since you must be knowing that any parent type can also hold the reference of subtype, that means I can use exception to handle any exception, because all the other exception classes are child classes of this exception class. Correct. So with this also I can have the same result, but the thing is, it is not a very best exception practice handling, that you try to handle all the exceptions through exception class itself. You should try to catch a specific exception and then move towards generic. So what actually you should do is, in this case, is you should try to handle what you can handle, and at the end, so that's what you do as a convention. So I know this code may throw an arithmetic exception, so I'm trying to handle that specific exception. Then I know that this code may throw an input mismatch exception, so I'm trying to handle that, but I may not anticipate all the runtime exception. So any other exception will be handled by exception. So at the end, you can use that. That is the convention. That's how you should use multiple catch blocks. And it has to be in the end. Even if you bring it at the beginning, that will be an error. As you can see now, you have unreachable code, because all the exception will be handled by this parent exception class itself, and you'll never be able to reach these two catch blocks. So this becomes an unreachable code. That is why this should always be at the end. Okay, so that is something about hierarchy and how you can use multiple catch blocks. As I said, from Java 7 there is also a multi-catch statement, which actually means you can have more than one exception in the same catch block separated by pipe. So same thing can be written as this: one exception, second exception separated by pipe. and in the end, at the end you have the object. With this you can't have any parent type, so you can't say okay I'll have at the end, so you can't have on any side, not at the right side. This is also an exception. This is also an error. Bringing it here, this is also an error. So you can't have any parent type and child type in the same multi-catch statement. If you want this, then you have to write it like this. So that's how you can write multi-catch statement Java 7 onward, where if exceptions are handled in the same way, you are just printing some message or logging it, then what you can do is separate them by pipe and write them in the same catch block. You don't need multiple catch blocks. So another keyword within the Java exception handling is finally. So when you use finally block, with finally you create a block, so that block is always guaranteed to execute. So whether you have exception or not, whatever code you have in finally block, that will always be executed. So as a convention, what you do in finally block is to close the open resources. So you may have some open resources like some file handle or DB connection, network connection in your code, so that you try to close in finally block. Why? Let us try to see with this code itself. So here also, if you see, we are using scanner and we are closing it here at line 20. But if we have exception, which we are seeing that happens here, right? When you try to divide by 0, or here when you give a wrong input. So you may have exception at line 12 or line 14 or line 16. So whenever exception happens and it is thrown, now we know that you will go to a catch block, right? Correct catch block, which will handle it, and it will continue afterwards. So it doesn't come back here. So if there is an exception, then you never reach this line, correct? Line 20. So your open resource never get closed, as you can see it here also. If I try to divide by 0, correct? So it, from this line it goes here, handles it, and then continues from line 27. It will never go back to line 20. So that is why any such open resources you should close in finally, because that block is always guaranteed to execute whether you have exception or not. So how you should actually write it is, should have a finally block, and there you should try to close it. So here again we'll have to make some changes, correct? Can put some message also here in finally. With that, if you see, I have something divided by 0. So now if you see, even if there is an exception which is thrown here, line 16, it still goes to the finally block. That means your resource is always closed. So that is the use case for finally, that it should be used for closing any open resource, because that makes it like a guarantee that your resource will always be closed, as we just saw. That if your exception is there which disrupts your normal flow, then you may never reach the code where you are trying to close your resource. But with finally, you will always do that. So that's what you will do with finally. Now as a last thing, let us see that call stack, which I told you that we'll see that example also. So for that I just refactor this same code with different methods. So now we take user input in one method here, correct? Then we divide in another method here and print result here itself. So now you can see we have three methods. So this is the calling method. So that's how you say it. So main is the calling method, which is calling this method, right? Take user input, and this is the called method. And for this divide, this is the calling method and this is the called method. So you go from, this is your call stack from main to take user input to divide. And if any exception occurs, it will go through this call stack in the reverse order. So first it will look here if this method itself is trying to handle it. No. If exception is not handled here, it will come here. If this called method or calling method actually, if this is trying to handle it, no, then it will come here. If still no, then it goes to default handler. So we can see with this. So if I give some again, if you see we have exception, and if you see this, right, so first it gets error here 31 line, correct? Then it goes here, still looking line 20. If this is also not handling, it looks here also line 8. So that's what you see, your stack trace, how it is going through your call stack in the reverse order. So I can handle it here or here or here. So you should always try to handle your exception as late as possible. I can handle it here. That means I can wrap this or enclose it within a try and then catch it here. So that's what I can write. So again the same flow. Error actually happens here. Your exception is thrown here. So exception happens here. Exception object is created. It is thrown. Then your runtime, Java runtime inspects. Okay, is this code handling the error or exception which is thrown? No. Then it goes up in the call stack. If the calling method is handling it, no, we have a try finally here, but only to close it. So one thing I'll tell about these combinations also, how you can use try catch finally blocks. But coming back here, so this is also not handling, no catch block here. Then it comes here. Here it finds some code which handles it. So it will be handled here. So that's how you can have a call stack. Now if you see, it is handled. It's going to finally to close that scanner. So that's what you mean by the call stack. So you go up. This is also known as your exception propagation. So your exception is propagated from where it starts. It goes to the whole call stack to find any code which can handle the exception. Now one more thing is these combinations. So you can see it here. So with the try catch finally, you can have a try block, then catch block, then finally block. All three you can have. That is also okay. Or you may have multiple catch block. That is also okay. Or I can have just try catch. That's what we started with, right? Try catch or multiple catch block. That is also okay. Or I can have try with finally no catch. That is also okay. So these three combination you can have. You can have all three, try catch finally or multiple catch finally, or you can have only try catch or try catch catch again multiple catch blocks, or you can just have try finally. So try should be accompanied by either catch or finally or both. So all these combinations are fine. You won't get error if you use any of these combinations. So that's about the Java exception handling using try catch and finally. That's how you can use try catch and finally block to handle your exception and closing your resources. So thanks for watching the video.